the periodic table, and in the vertical, we can call these vertical columns. Those are groups of elements. And an individual group, this would be pointing to group 2A or family 2A. In an individual group, you have many different elements, 1, 2, 3, 4, 5, 6 elements in this group or family 2A, group 2A. And like any family having DNA and similar physical and personality characteristics in common, this family or this group of elements in this column 2A has similar physical and chemical characteristics. Okay, so this is for any of the vertical columns. This is 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. These vertical columns have groups of elements that are a family. They share chemical and physical characteristics. So an individual row, this is the horizontal row shown here. An individual row in the periodic table is called a period. So that's why it's called the periodic table, is that they're organized as rows based on law of periodic properties, which we'll get to in a second. For an individual box, this is showing the individual box of chromium. And so this is chromium that has a element symbol Cr, and the top number value, that's a whole number value, is called the atomic number. The atomic number is like an address. Those are all the whole number values, and it's like an address that the number is equal to that element. So number 24 is always going to be chromium, or number 1 over here on the left is always going to be hydrogen. Number 2 over here on the right, top right, is always helium, He. So the periodic table is arranged by increasing atomic number, where starting from the upper left, like if you were reading the lines of a paragraph on a page, you would start from the upper left and read over, jumping over this empty space to the right. Okay, so that's the first line. The second line would have to go over and down to the next line. This is number 3 and 4, and then jump over to number 5. So these numbers correspond to those elements. The periodic table is arranged by increasing atomic number. 1, 2, 3, 4, 5, 6, 7, where they increase over and down. Okay. So the other number for an individual element is the decimal number value, and this is the atomic mass. The decimal number value is a calculated value, so that's why it's a decimal. It's an average mass of one atom of that element, and it's calculated based on using all the isotopes of that element. I know I haven't talked about isotopes yet, but we will. But it's using all the different versions or isotopes of that element that are present in nature and their abundance. So it's calculated, basically. And the higher the value of the atomic mass, the more mass that average atom of that element has. So we know that elements in a vertical column are a group. They're called a family. And this is an example of family 3A. So these are mostly metals, those to the left of the stair-step line, except for this boron, which is shown in gray. That's just on the stair-step line. So when there are elements, they're all different elements, but they are in the same family. They have similar physical characteristics, such as they're all metals. They also have similar chemical characteristics, and the chemical characteristics are that they will react the same in a chemical reaction. So this in family 3A, they are mostly metals, and one thing we know about metals is they tend to be solids at room temperature. Here is showing, you're going to see a spoon, but when you think about a spoon in your kitchen, it's a metal spoon probably, and a metal spoon, say made out of aluminum, is something that you can use when it's hot or even in hot soup, and it's not going to melt. So gallium is right below aluminum. It's in the same family, and it has similar physical characteristics. It looks the same. It looks like a metal. It's a solid at room temperature, but it's slightly different. So that's why it's the word similar physical characteristics and similar chemical characteristics. It's pretty close, but slightly different at the same time. Just like in your family, you share the same DNA, you share the same physical characteristics and maybe the same personality traits, but not completely the same in the same human family. So the same is true about this comparison of aluminum to gallium. They look the same, but this is gallium, a spoon made out of gallium. Looks like aluminum, right? Close enough. And then this is a cup with hot water in it. So that's just, it's not any kind of acid. It is just hot water. And look what happens to that spoon. So it's melted from a solid to a liquid, and it's dense, so it's fallen to the bottom of the water, and now is liquid gallium. Yep, see, just water, not any crazy acid.